Adiabatic Demagnetization. According to third law of thermodynamics, entropy of the system increases with increase in temperature and decreases with decrease in temperature up to the mark. When the temperature becomes absolute zero, the entropy becomes zero. And what if we study the entropy under the effect of the magnetization? What are the components that can be affected by the magnetization or magnetic field? Those are the paramagnetic substances. Paramagnetic substances are those substances that have unpaired electron arrangement, so they are attracted when the magnetic field is applied. So paramagnetic substance as a function of temperature in the presence and absence can be studied through this graph. Here the graph X and Y lines will help us to understand the relationship between the temperature and entropy with the absence and presence of the magnetic field. When we talk about the temperature is very high, it means that the entropy of the system is highly available. And if the temperature it is independent of the magnetic field, means that this is the range where the temperature is maximum T1, and at that point A S1 is means that entropy is maximum, and you can see here that this is the substance that is paramagnetic and it is having the zero magnetic field. B is equal to 0. In that case the temperature increases, means its maximum value is equal to the maximum entropy, that is point A. But in low temperature, when we talk about the temperature is decreased or it is lower temperature, then this temperature role with the entropy is affected by the presence of the, or it depends upon the magnetic field. To understand this graph well, we should be clear about some concepts that we are going through first. Okay, if there is any substance that is paramagnetic, you can say here this is a paramagnetic substance, and if we draw a graph between the entropy on the y-axis and temperature on the x-axis, temperature T2 is lesser than the T1 and entropy S2 is lesser than the S1. But this is the graph when no magnetic field is applied. This is a graph obtained when no magnetic field is applied, means that we are just studying here the effect of the temperature on the entropy. Entropy increases with the increase of the temperature. Temperature decreases, entropy decreases. Temperature increases, entropy increases, means that the T1 to T2, when it goes from T1 to T2, the entropy changes. When it goes from T2 to T1, it goes through from the S2 to S1, because here the T1 is bigger than the T2, but the entropy S1 is bigger than the S2. Okay, according to the law of thermodynamics, we have come to know that when the limiting temperature condition is applied, temperature is reaching towards the zero. At that time, entropy will be equal to 0. This graph and this portion of the graph is obtained when there is the absence of the magnetic field, means that the B is equal to 0. On the other side, this was about the X. And if we talk about the entropy and temperature relation, you must know this is directly related. With the decrease of entropy, obviously the temperature is decreased, and this is the graph Y that is about a different thing. Let's study about it. Paramagnetic substance get ordered by applying magnetic field. This is the portion where we are talking about when we apply the paramagnetic magnetic field here. When we apply the magnetic field here, you can see from this diagram, this small portion is showing a substance where the electrons are arranged. Here in this portion, electrons are not arranged, but in this domain, the electrons are highly arranged because the paramagnetic substance is affected and the electrons are arranged by applying the magnetic field. Randomness also decreases with the decrease of the temperature. You must know that there are two factors. One is the temperature, due to which the entropy is decreasing. Other is the magnetic factor that is causing the arrangement of the electron, and in this way the entropy of the system is decreasing, and in this way we are obtaining the graph line Y. So this is what we have studied till now. This is the point B where magnetic field is applied. Molecules or electrons basically are arranged by applying the magnetic field, and the second thing is that temperature is also decreased. So two factors can affect to the entropy of the system. Number one is the decrease in the temperature. This is decrease in temperature from going to T1 to T2, and the second thing is that by the application of the magnetic field. And here is a case where no magnetic field is applied, and you can see from the diagram or the graph that the entropy here is higher. Something more you must be aware before going through the next paragraph is that when we go from the B to C, it means that we are moving from the B to C point, and when we will talk about the C to B point, we will talk about the movement from the T2 temperature to T1, and the graph will, or the entropy will change from the C to B. So we are going to discuss these things. One is B to C and the other is C to B. The path BC. You know, B is the portion where the magnetic field was applied and the electrons are well arranged, and C is the portion that is inside or on the x graph. So when we move from the B to C point is in an adiabatic demagnetization, during which entropy of the system remain constant. You can see that at the S2 point, entropy of the system remains constant, but temperature of the system decreases from the T1 to T2. This process is called isoentropic process, because in this process temperature is changing, temperature is decreasing from T1 to T2, but entropy is remaining same as 2. The increase in spin disorder is compensated by decrease in disorderness due to lattice motion. Means that when we go from the change in the temperature, there is increase in the spin of the electron that is compensated by the decrease in disorderness by the application of the magnetic field. Overall, entropy remains constant. The adiabatic demagnetization is a useful technique that is useful for obtaining a system at very low temperature. About 0.05 Kelvin temperature can be obtained by using this way. Okay, when we move from the path C to B, first we have talked about when we move from B to C. Here is the case when we are moving from the C to B, means that temperature is increasing. We are moving towards the higher temperature, that is T1. So it means that the disorderness must be increased. So from moving from the T2 to T1, the disorderness should be increases according to the third law of thermodynamics. Entropy must increase but remains constant. You can see that one thing, you have drawn a graph about the entropy. That is number one is about the S1 and the second is about S2. And here you can say that temperature is changing from here like this, and it goes from this. Temperature, this range was T2 and this is about T1. So when we talk about this point, number one, this is B and this is C point. So when we move from the C to B point, you can see that entropy is not changing. Entropy is still the same, S1. Entropy is not changing, rather we are changing the temperature. Temperature is increasing from T2 to T1, means temperature is getting higher. The entropy should be increased according to third law of thermodynamics, but entropy is not increasing. It is remaining constant at the C point, at the B point. Why does this has happened? We will study it. But the entropy remains the same by moving from C to B, because magnetic field is applied at B point, which compensate the increase in entropy due to temperature. Yeah, temperature increases, entropy increases. But at the B point, you know that in the diagram it is shown at the B point entropy is not increasing, is remaining same with the C point, because at the B point magnetic field is applied, temperature is higher, no doubt. Temperature is higher than the C point, but here the magnetic field is also applied, means that the entropy will be increased due to the effect of the temperature, but by the application of the magnetic field that effect is cancelled out, because you know that magnetic field application causes the arrangement of the electron and decreases the disorderness of the electron or the system. So when we move from the B to C, the temperature decreases. Temperature decreases from T1 to T2 when we move from B to C. Then delta S must be decreased but constant. But it is remaining constant. What will be the reason? The reason here is that at the C there is no magnetic field. temperature decreases, delta S must decrease but remains constant. Why it is remaining constant? Because there is no magnetic field, means that there is not the effect of the magnetic field to cause the electron to be arranged or decrease the disorderness or randomness of the system. This is only done by the one factor, that is temperature. Temperature is decreasing but magnetic field is not there to affect it. It means that at the C point, the entropy will be remaining same. Now you will be more able to understand this graph well. This is the B point. Here on the B point, magnetic field is applied, and this is the C point where no magnetic field is applied. When we are moving from B to C, temperature is decreasing. The entropy of the system should be decreased, but it is not decreasing. It is remaining constant, that is S2. It is remaining constant, that is S2. Why is this so? It should be changed, but it is remaining same because in the C point, on the C point, there is no magnetic field effect. You can see it in the diagram. The electrons are random, and with the decrease of the temperature, the entropy decrease is compensated by the entropy remain higher due to the absence of the magnetic field. And at the B point, when we are moving from the T2 to T1, temperature is increasing, entropy should get increased toward the S1, but it is not increasing. Rather, it is showing that it's just moving from C to B. Why? Because here entropy increase from T2 to T1 due to T2 to T1 is compensated by the decrease in entropy by the application of the magnetic field at the point B. You can see it from the diagram. So this was all about the adiabatic demagnetization effect. It is highly important. Long question has become the part of the past paper variously in the different form, so you must be prepared for it.